Hello, welcome to today's Tech Talk. I'm your host, Jennifer Mavashev. Our topic today is how to take advantage of features in 7.1 and 7.5. Our speaker today is Richard Nicola, who is Nastel's VP of Product Development and Support. We hope you enjoy the webinar. Take it away, Richard.
Welcome to today's Tech Talk, how to take advantages of new features in Webster MQ-7.1 and 7.5. This is one of several Tech Talks that we've done on 7.1 and 7.5. We started out with an introduction. We then talked about multiple versions and coexistence. Now we're doing this section on how to take advantage of new features. And finally, we'll end up with migration scenarios. So let's start with looking at an overview of what we're going to cover today. We're going to start off with talking about some of the new dead letter queue settings. We'll then talk about channel security, object security changes, and finally the multiple transmission queues. Now, one of the things you may get the feeling today is that you're taking a test, because I've sat through the certification tests for MQ, and if you've done that, you know that there's a lot of questions about, well, if this option is specified or that option is specified, and the current phase of the moon is this, what will happen? Well, with a lot of these options today, there are many different ways they can be configured, and they do have to be reviewed, because sometimes those different options actually work together. So the first feature we're going to look at are changes in dead letter queue processing. This gets involved when messages can't be delivered. There were two main changes. First off now is that channels have an option, use DLQ, and that can be either yes or no, the default being yes. And yes basically says that the channel is going to use the dead letter queue, if there is one. And no says that it doesn't use the dead letter queue. Messages are basically processed out of band from the dead letter queue. Now, there are other options such as NPM speed that will affect ultimately what happens when the channel is sending messages and you have these interruptions. The second is topics, which is probably a more useful one than the channels, because topics now are becoming much more of an option for using instead of actually queues. You can subscribe to topics, messages can be sent out as needed, and so there's a lot of use for topics. But one of the challenges of topics is that if I subscribe to a certain set of topics and then I get tired of waiting, I take my temporary queues and I leave, then of course what happens is eventually somebody subscribes and say that subscription took a while to reach me, and at that point my application isn't there, thus no place to put the message, thus the guaranteed messaging can no longer deliver the message, and of course the action up to this point has been to put the message on the dead letter queue. There are now three options. You can specify as parent, which means to look to the parent object of this topic to determine the behavior. And then the two functional, use DLQ yes, which actually will use the DLQ. The topics will be published to the DLQ. And no, which again doesn't use the DLQ. And you'll also want to look at the MPM, the non-persistent and the persistent PM, MSG DLV, message delivery options, as they're associated with this. The key thing, though, again, is that you can get rid of these messages rather than filling up the dead letter queue with messages that can't be delivered. And, the key thing here is we could talk a long time about the dead letter queue, but the real option or the real quandary you have is it's kind of like a game of hot potato. MQ is guaranteed it's going to deliver that message, so as each piece takes it and hands it off to the next, that next piece becomes responsible. So, in this case, the sending application, it sends it to MQ. That goes on the remote queue. MQ puts it on the transmission queue. Once that's accepted, it can't turn around and say nope. It has to continue to push it down to the channel. The channel takes it, transmits it over to the other queue manager. And once the channel accepts the message and it's on its side, it has to do something with it, right? So it's like a game of hot potato. And of course, what we want to do is we want to make this as simple as possible, so that if there are cases where messages can't be delivered, that you can do something with it besides playing a game of hot potato. So the next feature that we're going to look at is the channel access control changes. And this one comes from typical requirements that we see in MQ environments. The first being that I want to enable our administrators and client applications to connect to the queue managers with the minimum amount of configuration required. And then the second requirement is I want to ensure that no one can connect to the queue managers without using SSL, right? We want everything to be locked down as much as possible. Well, those two requirements kind of go against each other, right? And it goes like the old saying, right? You can't have your cake and eat it too, which I actually didn't understand originally. I always thought, well, if you don't have a cake, how could you eat it? But what it really means is, you know, if you have your cake, which means you eat your cake, you can't eat your cake and still have it, right? I mean, you have to, if you eat it, you don't have it anymore, right? So that's what it's talking about here is we're saying the same thing. We can't be secure and lock everything down and at the same time require the minimal amount of configuration. They just don't happen. So with 7.1, though, you can get closer, and we talked about this in the summary with the ability to block or restrict access by IP addresses and users, to be able to set the MCA user field, which is a very important one for client applications specifically, and queue manager connections. You want to be able to specify that based on IP address and still provide access to the queue manager. So in this topic, there are really two things that are generally applicable. There are a set of global rules. The global rules apply to the queue manager as a whole, and these can be used to basically isolate queue managers from one another, such as production from the test environment, so that you don't accidentally have an application that connects to production and deletes all the messages when they meant to be connecting to the test system. And then there are channel rules which apply on a channel by channel basis, and these also allow for an increasing level of specificity, so that you can restrict who can use a given channel, and then further on grant other accesses to other users and so on. So it's a more granular form of security. We'll walk through those scenarios here. So the first example here at the top are a couple of examples of using block adder, which again is blocking addresses from being able to connect at all to the queue manager. And these can be either IPv4 or IPv6 addresses, generic specifications that basically say these are IP ranges that cannot use or connect to this queue manager, so we're blocking them. The bottom examples are now using the type address map, where we're actually now using addresses to allow access to the channels. Now, the first one though is very, very broad. It basically says set a channel authorization for all channels where the address is all addresses, and provide no access. So the no access here for user SRC is basically saying that you can't access the queue manager. So if that was the only definition you had, you basically would lock down. No one would be able to connect to any channels across your queue manager. So then you would start broadening it out. So at the bottom one is an example where I've said, well, okay, localhost 127.0.0.1 can connect to channel 2. That is allowed. Okay. However, we still said for the user SRC option that it's the channel definition that ultimately defines the privileges. So the MCA user and other settings are actually going to come from the channel. And then one other useful option is there is a warn mode, which can be used so that you can basically set up the definitions, set them to warn mode, and MQ will simply alert you when it would have not allowed access. Obviously, for production, you would want to not be running in the warn mode. One question that comes up is the difference between block IP, which has been available for a while, and IP filtering that we've just talked about. And the first answer is that they are similar, right? I mean, they're both trying to basically block access to the queue manager. The difference comes is that block IP, of course, was a separate installation. It required its own setup, and the IP channel security that we're talking about now is part of MQ itself. The second, of course, is that the channel security, in fact, because it's integrated, actually goes a bit further in what you can set up. But in common is that they both still are just forms of security, and you probably still want to have a firewall to prevent any unauthorized access. Let's talk about some of the other options, though, that are available besides just blocking addresses. Here we're actually identifying the MCA user mappings that can be used. So here we're using address map. And what we've said is that any IP address that's in the range of 1100 anything, when connected to this channel client con, gets to be an MQ admin. Okay, now again, those have names that would need to be defined separately, but they define the the access rights from these IP addresses, and basically any of them that tried to connect to client con would be getting an MQ admin user. Similarly, the bottom example, we've got another channel. Here we've specified again our IP address range, but we're using a queue manager map, not an address map. So this, of course, is used for queue manager to queue manager connections. Now, both of these are just fragments. You want to be using these with the other security definitions. And if we go back and look at our original requirements, not only do we want to make it easy to lock down, but we also had a requirement to be very secure, which we haven't touched on yet. So if we look at the new options for SSL, there's also a set of channel authorizations for that. That's the SSL peer map. And with that, we basically are going to match up the certificates that are being used and the channels that those certificates are valid for. And the remaining options, use SRC channel, MCA user, and so on, can all be used in conjunction with the type SSL peer map as well. This link at the top is a useful link if you're going to be doing much with SSL. It explains, how to set up certificates and all of those things for your partners. A remaining set of definitions that we haven't talked about are the user and user map and block user map. This allows us to set up on a per user basis who can access this channel, just like who can access queues and MQ and so on. And then again, whether they use the channel mappings, whether they have no access, and so on. So you can do that. And again, you can also use the block user to specifically block a list of users from using a channel. And probably one of the more interesting ones of this is the one at the bottom, the asterisk MQ admin user list, which is a predefined user list that means all users that have administrative privileges. So one of the challenges that, of course, that some companies have is that the MQ administrators have rights to pretty much everything. That's, if you're part of the MQM group, then you're kind of all powerful. This is actually a way of preventing you, the administrator, from being able to connect and use this channel. And so finally, we put all these together. We've got the global rules for filtering with block adder. We've got restricting access using address map or user mapping. We've got SSL rules for mapping who can connect securely with the SSL peer map. And then, of course, we can actually, permit the right users to use the channels, again, using the address map as an example. And when you put all these together, then you can basically lock things down relatively securely, not letting anybody have access except the ones that are supposed to have access. And then one final word also on these new channels in 7.1 and 7.5, and that is that anything that you define new will have a channel authorization activated by default, which means that even though you could have defined a new channel exactly the same way that you would have in 7.0 with an MCA user value and having it all set up, when you try to connect to the channel, you won't be able to. And there's two ways of resolving this. Option one, which is basically altering the queue manager to set channel authorization disabled. If you do that, you might as well forget everything else I talked about in this session, because you basically turned off the channel authorization. So certainly I don't advise that one. The second option is to basically create a channel authorization that permits the user to have access to that channel. Okay, let's talk about a couple of the other security enhancements. The first one was object authority for non-existent objects. The challenge here was pretty simple, is that you have security requirements that say we need to set up security, but you couldn't set them up until the object was defined. And of course, once you defined the object, until you set up security, anyone could access it. So you wanted to be able to lock it down, but you couldn't because you hadn't defined it yet. So with 7.1 now and above, you have the ability to basically issue a set MQ-8 command, and with that command you can basically create objects, or create definitions for objects that don't exist. And that's actually the demonstration here. The same command done on a 7.0 queue manager and a 7.1 queue manager. The top one returned an error saying I can't find target queue, so I can't authorize it. The bottom one said, yeah, fine, it's now secure. So now I've secured it, I can go define it, and nobody could access it. Okay. The next part of object authorization is remote object authorization. And what I'm showing here are a couple of examples of using a remote queue. The top example uses a remote queue definition that ultimately causes the message to go onto a transmission queue across the channel to the target queue on the remote side. At the bottom, we're actually using a different example where we're actually sending the message directly to target queue. Now, obviously, it still goes through a transmission queue and over a channel and all those sort of things, but the application itself does not use a remote queue definition. It sends the message directly. Now, from an MQ authorization perspective, the remote queue on the Queue Manager 1 here is actually a local object. Okay, so it's a local object that just happens to be the definition of a remote queue. So this topic doesn't apply to it. It applies to the second example where the object, target queue in this case, is in fact a remote object to Queue Manager 1. And so we now have two definitions that are similar but different. The top example would be how we would secure the remote queue definition locally on Queue Manager 1. This bottom example with the -T RQM name is actually pointing or securing the target queue on the remote queue manager, right? So this is the new capability, the ability to create a object authorization for a queue that exists on a remote object or is a remote object. And finally, the last topic for today, cluster transmission queues. These were added, this change was added in 7.5, which allows you to now have multiple cluster transmission queues and potentially increases your throughput, right? So this is the main goal, is to increase the throughput through the cluster environment. There's two ways that you can do this. The first is at the queue manager level. There is a new attribute, a DAF CLX queue, and you can see here the default is SCTQ, and or it can have a value of channel. SCTQ stands for System Cluster Transmission Queue. That's my guess. And basically what that says is that you have a single system cluster transmission queue, as you do today. If you set that to channel, then what gets done is that for each unique queue manager in the environment, there is in fact a different cluster transmission queue that gets created that's going to send messages for that environment. That's the first option. The second option is there is a queue attribute as well, the CLCH name, the cluster channel name, and that allows you to point to a generic cluster channel name. Now this is not a specific channel, this is a generic cluster channel name, and it's a way basically that you can define generic names to map to a group of channels that are part of a cluster, and you can associate this queue with it. Again, that would allow you a way to basically spread the work for this queue to different transmission queues than other queues for the same cluster. Again, it's an option you can take advantage of if there's a specific need in your environment around cluster queues that have different characteristics. Okay, at this point, since I'm sure that everything is either perfectly clear or at least clear as mud, as they say, I'd like to open it up for questions.
Okay, so we're here for questions. Does anybody have any questions? You can put it into the question box. Okay, so okay, here's a question. With IP blocking, why do you say that you need to have a firewall?
Thanks, Jennifer. Yeah, so good question. That had come up a couple of times. I guess the basic reason is that you don't want to rely on MQ as your source of firewall protection. Basically, I mean, you still want to have a firewall. You can never have enough firewalls. It seems like these days they got firewalls around firewalls around firewalls. But the key point is you don't want to rely on MQ to be your only source of protection.
Okay. Okay, so does anybody have any other questions? Okay. Okay, here's one. The various channel options seems very complex. How do I know that I have it correct?
Yeah. Okay. It's another good question. The answer is really by just trial and testing. I mean, you need to test. You need to run with the the warning mode. You need to make sure that that you've validated by attempting to connect to, say, from a if you, for example, you wanted to block your server, or say your production from the you wanted to isolate production from test, right? Well, then you better make sure that you run a test from the test system to make sure that it can't connect to production and that's working properly. Certainly run with the warn mode, initially to see what in fact you're doing, and work your way into it. It's going to take some amount of verification.
Okay. Here's a question over here. I have ZOS, and RACF has allowed me to create security definitions for objects that do not exist. So is this new?
Okay, let me see if let me repeat that, make sure I got it right. So they have ZOS and RACF, and basically they're saying, well, we could the security definitions we could already do that. So yes, the answer is yes. That has been available for ZOS. I should have said that, I guess, more specifically. That the new feature is targeted at the distributed platforms, which did not have that ability before. That would include all the Windows, Linux, even the iSeries versions. Okay. Were there any more questions, Jennifer?
There's a question right over here. With this detailed level of security, how is this performance affected?
Performance. Generally, it's a good question. You think about it. What's going to be affected is going to be connectivity time, right? When it tries to connect, most of the options are going to affect what happens when you issue a connect call to the to the channel, right? So obviously, if you've got a lot of applications that are connecting, disconnecting, connecting, disconnecting, and so on, then then you might see a difference because they're going through more logic. Once they're connected, you're not going to see it. So I would say overall you're not going to see a significant performance drop.
Okay, so we have another question that came in. How does the channel auth type sleeper map differ from security than usual SSL clause?
Okay, hang on, let me look here and see. I guess, okay, the basic difference is that the channel auth is now a separate set of specifications that in fact can have, as I mentioned in the presentation, can be part of a set of definitions, right? So I can have multiple SSL or channel authorizations, some of which specify SSL, some of which don't, and so the biggest difference is the fact that it's now part of the channel authorization. Similar functionality in that it's basically checking a certificate that's coming in. The difference really is in the hierarchy.
Okay, so here's another question. Where would you see the warn messages, and is it oblivious that there is a warn error? Obvious, sorry.
Obvious
that
okay,
there's
yeah.
one. Yeah.
So the warn messages are going to go to the log, just like any other channel start and stop message. And yes, they will have a specific error number. I don't have that available in front of me, but yes, they will have a specific error number to let you know that it's a warning message that the channel has, that basically it is it's given access that it wouldn't have otherwise given access. Okay. Any other questions?
Any other questions? Please put in. Nope. Okay. Well, thank you for attending the webinar. If you want, you can always go onto nastel.com and see it. It'll be on demand by the end of the week. And that's it.